Hello all, welcome back to Aislyn Technologies YouTube channel. Today we're gonna see about identification of mature level and count of Nutmeg using color space segmentation algorithm. Yeah. This project is based on YOLO V5 custom data. So we're gonna do this now. I will explain you the abstract. Here, our abstract represents a new method for identifying and counting nutmeg samples based on their maturity levels using image processing. The approach involves transforming raw RGB images of nutmeg into different color spaces, which helps distinguish color-based features more clearly. A color space segmentation algorithm is employed to separate regions corresponding to different maturity stages from the background and the other objects. The method is designed to work under various lighting conditions and has been shown to accurately detect both maturity stage and the number of nutmeg samples. The proposed system offers a more efficient, accurate, and cost-effective solution compared to traditional manual grading, making it scalable for use in agriculture. It can be generated with existing technologies like automated sorting mechanism, allowing for real-time processing. Additionally, the system is optimized for a low computational demands, making it variable learning to enhance classification accuracy and expanding the use to other crop with similar needs. Ultimately, this approach demonstrates how image processing and color segmentation can revolutionize agriculture quality control by reducing reliance on manual methods. Here, our introduction discusses about the importance of identifying the maturity level and the count of nutmeg for quality control and post-harvesting processing. Nutmeg is a valuable spice, and harvesting it at the right maturity is crucial to maintaining its flavor, aroma, and nutritional value. Traditionally, this task is done manually, which is labor intensive and prone to human error. As the agriculture industry moves towards automation for improved efficiency and consistency, new technologies are being adopted to enhance quality control. One such technology is color space segmentation, which transforms images from a standard RGB format to other color spaces such as HSV, LAB, or YCP-CR. These alternative color spaces are more effective for distinguishing feature based on colors, making them more useful for identifying nutmeg maturity stages. This method also helps to isolate nutmeg samples for complex background and overlapping objects, making it suitable for both field and factory environment under varying conditions. Here, our method uses advanced image processing algorithms to automate the process of assessing the maturity and count of nutmeg. This algorithm can account for environmental factors like inconsistent lighting and shadows, ensuring precision and accurate results. By accurately distinguish mature from immature nutmeg, the system can optimize harvesting schedules and reduce waste for incorrect sorting. The system offers more reliable, scalable, and effective alternative to manual inception, reducing labor dependency and improving performance in large-scale operation. Yeah. Now I'll explain you our problem statement, our objective first. Here, our objective is to develop a color space segmentation algorithm for accurate identification of nutmeg maturity level, leveraging alternative color spaces to enhance the differentiation of color features associated with varying stages of ripeness. By developing a robust counting using object detection algorithm that can accurately detect and count individual nutmeg fruits in the images, even under varying environment conditions such as lighting, inconsistency, and complex backgrounds. Yeah. Now here's our block diagram. Based on this block diagram, we have done our project. Now I will explain your block diagram. Here, first I will collect our data set of ripe and unripe of the images of nutmeg, and then we are doing pre-processing, such as resizing our image for a consistent dimension, like all the images should be in same consistent level, and the normalizing of pixel values to required. That is nothing but our images will be converted into -1 to 1. That is a format will be dual into our model. That's what we're doing here. And we are removing the noise for our irrelevant images in the images. And we are doing color segmentation, and we are labeling. By using a image annotation tool, we are labeling it in YOLO format. And we are splitting the data set into training and validation set to before giving into a model. And then it will detect and count ripe and unripe fruits in the new images or videos of frames. And it visually predict our bounding box with the class labels, whether it's a ripe one or unripe one. It will come like that. Now I will show you our data set. You can see once. Yeah, here is our data set. Okay, these are the images we got trained. Okay, this is the ripe thing, and this is the unripe one. We're gonna label it accordingly, and then we giving it to our YOLO prediction model. Yeah, and these are the labels based on the images, and this is a validation file, and these are the validation images. Now I will show you how to train this. I have trained using command prompt. Yeah. Now here we have Python train file, right? We, we're gonna access this file and this data. So inside this data, you can see our path will be settled. Yeah, this is a path. This is a YOLO dataset training path and YOLO custom path here. Now I will try this. First, we should access a Python file. So that Python train.py and then batch nothing but samples to be thrown for each epoch. We're going to do 16 samples. And an epochs, we're going to do epochs nothing but iterations. Process, we're going to do 100. And then we're going to tell the model to access the data.yml file. So that we set a data set path so that it will access that file. So that's a data.yml file. YAML. Here we're gonna initialize weights. We're gonna use here we're gonna initialize weights. We're gonna use YOLO V5 small version. YOLO V5 yes smaller version dot pt. Yeah, you can see the same YOLO V5 yes dot pt and data YML try. We want to use this version and we're gonna access this data based on this total. Now I'll run this, you can see once. Yeah. Now trading is gonna be start now. Okay, here you have an error now. I will rectify this now. What the error is in missing path is that in our data file. We're gonna do this now. Yeah, that's it. Copy this too. And then we should do it as local variable. Practice it in local. Yeah, that's it. Save the file and enter the code again. Here our previous error is dataset is not found because of invalidation path. Now our training have been started. Yeah, this is our model we built. This is our model.yml. Yeah, now you can see our training is gonna start now. I gave 100 approx, so it will take around 40 minutes to do this. Yeah, we can do this. Okay. Likewise, it will run for 40 minutes so that we will skip this part and I'll show you the other thing after this. Yeah. And then after our training, our runs in these runs files, it will be saved here. Yeah. Now these are the train batch files what we have run and then our predictor thing is there. So you can see this. And then these are the best weights. Now we will take this weight. So this is our model. So you will take this model and we're going to build the code now. That's our testing code. Okay. And this is our confusion matrix. You can see. Yeah. Now I'll show you our final code. I'll open final code. Yeah. Here you can see. Yeah. This is our final code. Our custom YOLO model is loaded here. That's what is this. Now I'll run this. You can see once. Yeah, now you select an image for detection. So our dialog box will open backside. So this is our dialog box. We're gonna select any one of the images. Choose from validation. Yeah, you can see this. The predicted thing is unripe. And the results will be printed here. And the results will be printed here. The predicted is unripe. And this is the confidence score of this and this. Yeah, I'll do for other thing. You can see once. I'll predict for other one. You can see that also. Yeah, our loaded model, our YOLO model is loaded. Yeah, now we can select an image. We can select this image. Yeah, you can see you can see this is the right one and this is the unripe one, and you can see the confidence score, right? Yeah, this is the thing how it will work. Thank you for watching this video. If you have any doubt regarding this video, you can leave a comment in comment section. And don't forget to like, share, and subscribe. Thank you.